Okay, in this chapter, we're going to keep learning about sequences and series. In this section, we'll focus on geometric sequences and series. So that's when you multiply one term by a specific constant number to get the next term. So the definition is the ratios of consecutive terms are the same. So if you take the second term divided by the first term, that value r is going to be your common ratio. That's what we're going to call r. Alright, so the third term divided by the second term also equals r, the fourth term divided by the third term equals r, the 100th term divided by the 99th term equals r. Okay, so you just multiply each term by the same number to get the next term. So if you needed to show something, if you wanted to prove if a sequence is geometric or wasn't, you would just take consecutive terms and divide them. And if you get different answers, alright, 9/4 is equal to like 2.25, not equal to 4, so right there you know it's not geometric. Okay, so just like an arithmetic sequence, a geometric sequence has a formula. So to find the nth term, you could take the first term and multiply it by the common ratio to the n-1 power. Alright, the reason why is like when you have 1 as the first term, when n is 1, like this first term would be a sub 1 times r to the 1 minus 1 power, which is just r to the 0 power, which is just 1. So you get the first term. Then for the second term, if you plugged in 2, you already have the first term, you just want to multiply the first term by the common ratio once. So 2 minus 1 gives you a sub 1 times just r. Alright, that'd be the second term, third term, fourth term. So remember this n minus 1 part when you're using this formula to find the nth term. Alright, so let's practice a problem here. So write the first 5 terms of a geometric sequence whose first term is 3 and the common ratio is 2. Then plot them on a set of coordinate axes. So, I mean, one way you could do this is to just write your first term, and then since the common ratio is 2, then just double each term. That's what the 2 infers. So the next one would be 6, the next one would be 12, the next term would be 24, the next term would be 48. If you wrote the nth term formula to do that, it'd be the first term, which is 3, times the common ratio, 2, to the n minus 1 power. Okay? So you can leave it like that. That's fine. And then if you wanted to, like, find the third term directly without having to find the second term first in like a recursive way, you would plug 3 in for n, and you get 3 times 2 squared, 3 times 4 is 12. Boom. Bing, bang, boom. Done. Alright, now I'll show you how to graph this on a calculator. So let's do it. Okay, so open up your calculator, hit the home button, open up a new document, and add a graph. Then we're going to change the entry to a sequence. And you can just hit sequence here. Alright, and then we're going to type in the formula. So the first term I think was 3 times 2 to the n minus 1 power. We have to use n, not m, because that's how it's defined here. Alright, we don't need initial terms because it's not recursive, and it's going to find the first 99 terms starting with n equals 1. Alright, and you could see, if we zoom out a little bit, that this kind of looks exponential in a way. And that's because it's pretty much going to look exactly like this graph of this function, 3 times 2 to the x minus 1 power. It's the same exact graph, except its domain are just positive integers. So when you graph a sequence, it's just going to be dots. It's not going to be continuous. Alright?